Section 8.4 is pretty difficult to kind of wade through. So what I want to do with this video is just take some time and kind of cut through what you really need to pick up from some of the things that I think are a little bit more difficult. First thing I want to talk about is the divergence test. Okay, it basically says, and you can read, you can get the formal presentation of this test from your textbook, but basically says if you've got a series of terms a sub k, if that series is going to converge, then the limit as k approaches infinity of the kth term has to equal 0. Okay, so I'm talking about if this series converges, then this is true. And how's that a divergence test? Well, the flip side of that says that if this is not true, then the series is not going to converge. So we can say that if you take a look at the limit as k approaches infinity of the kth term of your series, if that limit is not equal to 0, then the series diverges. Okay, so this is a test to determine whether or not a series is going to diverge. It is not a test that will determine if the series is going to converge. So if you work this and you get the limit to be equal to 0, the test is inconclusive. If you get the limit to be something that is not equal to 0, then the conclusion that you draw is that the series diverges. So here's an example. If I had the series, if k starts at 1 and goes to infinity, of k squared over 2 to the k power. To determine if the series is going to diverge, you're going to take a limit as k approaches infinity of that general term, k squared over 2 to the k. So as we work this limit, you first of all, I hope, recognize that this is going to be equal to infinity over infinity the way it's written. So L'Hopital's rule would apply. So we can look at the limit as k approaches infinity of 2k hang on. Okay, the derivative of 2 to the k, since that's an exponential function, would be 2 to the k power times the natural log of 2. And if you look at that the way that's written, we've got infinity over infinity still. So you apply L'Hopital's rule again and look at a limit as k approaches infinity of 2 over 2 to the k times natural log of 2 quantity squared, and that is going to go to 0. So this is an example where our test is inconclusive. Because our limit does equal 0, the only thing we know for sure, well, we don't know anything for sure. What we know for sure is that this test doesn't help us. So you'd have to do something else. Now to look at another example, suppose we've got the series if k starts at 1 and goes to infinity of the square root of k squared plus 1 all over k. And we're going to take a look at the limit as k approaches infinity of that quantity. Alright, so we're going to divide every term by k, which under the square root would be k squared. So looking at limit as k approaches infinity of the square root of 1 plus 1 over k squared over 1. And that limit, since 1 over k squared goes to 0, that limit is approaching 1. So because we don't have 0 here, we can say that our series diverges.